So in this video, we will be continuing on with the trigonometric substitution from our last video. So I highly recommend that you go and watch that before watching this video, since in this video, we'll be continuing on more complex examples. And I will be giving a short recap of what we did. So we have three cases where x is equal to a tan angle delta, and x is equal to a sine delta, and the last one is x is equal to a secant delta. And the main things that you need to remember are the radical x squared minus a squared for secant. For tan it is x squared plus a squared, and for secant it is a minus x squared. So now let's jump into our next example. So yeah, also you need to remember these common integrals. This is the first example that we did, second, third. Now let's move on to our fourth. So the question is integration of ln of 3 over 4, and the upper limit is ln 4 over 3 et over 1 plus e to the power of 2t into 3 over 2. So the first thing that we notice is that this is not ready to use trig substitution, not use substitution. So we somehow need to modify this or use u substitution first to make it in the format of that radical something over something. So let me rewrite this part, the denominator, as 1 plus e to the power of t, and this is squared, and this entire thing is 3 over 2. So which substitution do you think we should use here if we go back to our three cases? However, we cannot use trig substitution first, since this is not a polynomial, this is an exponential function. So first we need to somehow turn this e to the power of t into something else like a u. So first we need to use u substitution. So what you can take u here as is e to the power of t, and du here will be e to the power of t also. So here what we can do is we can replace e to the power of t by u, and now we see that we have something like the trig substitution here. So here we are going to do two substitution. First we're going to replace t with u, and then we're going to replace u with delta it's the other way around. So first t to u, and then u to delta, and then once we integrate all this, we need to go back like this. So now we replaced e to the power of t with u, and the du here is gonna be dt. So dt is gonna be du over et. So we realize that we can cancel this one over here. If I write it down here, let me write it. So here et, this part over here, is du as we wrote over here. So we can replace this entire thing by du. So I'm going to write it below now. This is going to be equal to, I'm going to leave the limits for now, since we need to go back to what we have, t, and then replace it. So for now, let's just leave it. It's going to be du over 1 plus u squared all to the power of 3 over 2. Now we can start substituting u as our tan delta, and a here is going to be 1, since there's a 1 here. And again, if you're not understanding this video, I recommend you to go back and watch my previous video, which was explaining each and everything, since these are more advanced and complex examples. So the coefficient of tan here is going to be 1, and du is going to be simply secant squared delta d delta. So now we can replace u with our tan now. So now we need to replace du with this part over here first of all. So it is going to be equal to, what is du here is going to be secant squared delta d delta over, now it's going to be 1 plus, now u, as we mentioned before, is tan delta. It's going to be tan delta squared, and then 3 over 2. So pretty much simple till now. So now we need to somehow simplify this. And here we realize that we can take 1 to the power of 3 over 2 and it still remains 1, right? So we can just do this here, and this power is only on tan here. And actually I can get rid of these brackets also and just write here. I'm just simplifying things up, since there was a 3 over 2 to the power of 1, which is just 1, and we can just put it on the top of tan squared here. And also we realize that 1 plus tan squared is simply secant squared, right? Delta. So over here what we can do is we can replace 1 plus tan squared delta in secant squared delta. This is a normal substitution or a normal identity that you need to remember. That is 1 plus tan squared delta is equal to secant squared delta. And now you can realize that we can cancel stuff out. Now this is just simple exponential simplification. It's secant squared to the power of 3 over 2. So this will cancel out with this, and all will be left in the denominator is secant to the power of 3 delta. And this now can be simplified to integration of 1 over, or I can write d delta over secant delta d, oh yeah, I already wrote that, or we can write 1 over d delta. And you should know that 1 over secant is equal to cosine. Since secant delta is equal to 1 over cosine, so 1 over secant will be equal to cosine, since we're just flipping it. So here 1 over secant is equal to cosine delta d delta, and the integration of cosine delta is just sine delta. So now we have reached the integration. Now what is left to do is to go back to our t here, to u first and then to t. So here we need to go back to our equation here, which is this one. So u over 1 is equal to tan, and we know that tan is twa, so that means opposite. So u is the opposite side and this is the adjacent side, and we need sine over here. So if we draw the right triangle, let's call this the angle delta, or yeah, delta, and opposite side is u here, adjacent is this one. So the hypotenuse will be radical u squared plus 1, and to find sine here it will be opposite, which is u, so we can replace sine with opposite, which is u, over hypotenuse, which is radical u squared plus 1. So now we have went back one step. Let me make more space over here. Actually, I'll write it here. So it was opposite over hypotenuse plus 1. So now we need to go back one more step, which is to t. So if we go back up and we notice that we replace u with e to the power of t. So wherever we see u now, we'll replace it with e to the power of t, e to the power of t here, and this will be e to the power of 2t. And that's it. Also, we also need to replace the limits here, since we're given two limits. So it was ln of 3 over 4, and the other limit was ln of 4 over 3. So all that's left now is to plug in these two limits, the upper limit minus the lower limit, and find the final answer, 1 over 5. So one important thing to keep in mind here is that remember that we were given 1 plus e to the power of e to the power of e 2et, and in our normal form for trig substitution we are given a squared plus b squared, or sorry, it's x squared here plus a squared, where a is a linear function. It cannot be something like e to the power, it cannot be an exponential function. So that is why we used first of all u substitution to get in the form of be able to do trig substitution, and that was why we need to know everything here. So u substitution, and then we had to do trig substitution. So keep that in mind. it always has to be in the form of radical x squared plus a squared, where a is a linear function, where a is an integer and x here, or whatever this part here, is a linear function. So let's move on to our next example. It is the limit of 1 and e and the dx over x radical 1 plus ln of x to the power of 2. Let me write it again. It is 1 plus ln x squared. So first of all, we notice that we need to use trig substitution, but this is not in the form since ln x is not a linear function. So first step here is to take u as ln x, and the of course the trig substitution that we're going to do is u is going to be equal to a tan delta, and since we have the coefficient or a as 1 here, it's just going to be u is equal to tan delta, and here du is going to be equal to secant squared delta, and here is going to be equal to 1 over x dx. So now let's go back and replace our first u here, which is going to be, I'm going to leave the limit for now, with dx over x, and we realize that this x I think will be cancelled out, since once this goes over there, dx is going to be equal to x times du. So I can just replace this with du, and this x will be cancelled out. 1 plus u squared. Now we realize that it's in the form of using trig substitution. So now let's start with this part. So now du is equal to secant squared delta d delta. So here I'm going to write secant squared delta d delta, and u here is equal to tan delta. So I'm going to replace it with tan delta squared, and we can just simplify this denominator. So 1 plus tan squared is secant squared delta, and the radical of that is equal to secant delta. So I can replace this entire thing with secant delta, and now we can simplify this down, and we will be left with integration of secant delta d delta, and we know that the integration of secant delta is just simply ln of secant delta plus the tan of delta. And now we need to go back to our x here. So first step again is to draw our triangle here, and we know that tan delta is equal to u. So we know that tan delta, let me write it over here, is equal to 2a, so that means opposite. First of all, let's just write this over here, what we have over here, and now we can say that this is the opposite side, and adjacent, opposite over adjacent, yeah, adjacent is 1. So if now we draw the right triangle, and this is the angle, u is right here, this is 1, and this sign is going to be u squared plus 1. So now we can find secant. Now since secant is 1 over cosine, so if we find cosine and we flip it, that will be equal to secant here. So cosine is so adjacent over hypotenuse is going to be 1 over hypotenuse, which is this one, and now we flip it again since we want secant, so it's going to be equal to just radical u squared plus 1. So this part is going to be replaced with radical u squared plus 1, and tan we know it already, it's just u over 1, which is just u. And now the final step left is to substitute back what we substituted for u, which is ln x right here. So replace all the ln x, u with ln x. So let me just erase all this now, since we're done with this step now. So now ln, again ln, so it's going to be inside the radical is going to be ln x squared plus 1 plus ln x close the brackets. And now we need to find the limits from 1 or e to 1 or 1 to e. The upper limit is e and the lower limit is 1. And guys, remember that ln of e is equal to 1. So I'm not going to go in details here. I'm going to write the final answer, which is, or you can just replace x with e first and type it on your calculator, and you will get the final answer as ln of radical 2 plus 1. And if you want to see the workings, I can write it here. So it's going to be ln of absolute value radical ln e squared plus 1, and this part is just going to be 1 since ln e is just 1, plus 1 plus ln e, which is also 1, and then minus ln of again ln x, which is this time is going to be 1, and ln of 1 is 0, as you know, so this is 0, plus 1, and I forgot the radical here, plus ln of 1, which is also 0, and here you get the final answer as this one. So that's all for this video. I hope you understood this topic, and if you have any questions, you can ask them in the comment section. And also one more thing I forgot to mention is that for limits, you can directly type on your calculator and get the final answer to recheck if you have to show your working and what so not. But let's say you were not given the limits over here. Let's remove them for now. So all you have to do is you can just try some random numbers. So this is a shortcut method to recheck your final answer. So just try like 0, 1. If it gives you undefined, let's try 1 or 2. And whatever number, let's say you get on your calculator, let's say 0.0156, something like that. I'm just guessing. What you got in your final answer, you will substitute those same two values that you used over here. Let's say 1 first and then 0. And if you get the same answer, this means your answer is 100% correct. So I will be making a short video on showing guys on the calculator, of course, and stay tuned for that, and hopefully it will be soon. Thanks for watching.